Management's panel review. And in the panel review, Tim will present the project he's completed in these 2 months. And then we will have a Q&A session for you to submit any questions or anything you'd like to know. Okay, so let's welcome Tim.
Hello everyone, my name is Tim, and this is my panel review, and my topic is the CDA inspection in test area and FNS practice. And first is my self-introduction, and I'm now studying in Cheng Kung University and major in engineering science, and it's my first grade for the major degree. And I like to play basketball, and also like to read some novels and watch movies. And this is my agenda. There are 3 parts of my panel review. The first is CDA inspection in test floor, and I also have 3 subtitles for this part. The first is CDA distribution in MB third floor. The second is test tool usage of CDA analysis, and I will do some simple summary for the CDA research. Second part is facility management system. I do some practice for it. And final is my internship sharing. And I will use the playbook 10 step to report my CDA research. And the first step is understand the current state. This is the facility CDA system. In this system, we have 3 parts. The first part is the red. We have compressors. And the second part, we have a dryer in the middle part. And finally, we have a filter. And the input port, we have CDA output pressure for 6.5 bar is about 95 psi. And this is the CDA distribution in MB third floor. You can see many colors in this picture, and it means the handle type. And different color means the different handle type. Like we have Castle, H4, Rascal, YK, H, and MLT-MT. And in distribution, we have 2 main pipe and 1 sub pipe in this floor. And this is the main tester in MB third floor. We have 4 kind of tester in MB third floor. And the main type is iFlex. It connect with this type of handle, like we have H4, Castle, LT, MT, MT-DGG, Rascal 3000, H, and YK. The next is the Teardyne. We connect with the H4 only. And J750, we also connect with the Rascal 3000 only. And the final is the J750HD. It always empty, but it sometimes will connect with the H4. Next is the handle in MB3F and I major. And there are 3 information for each type of the handle, like H4. The CDA input port, we have 4 in the H4. And the next is the site quantity. The site quantity means that H4 can test a material in once. So the site quantity means the handler can test how many material in one procedure. And the final is the test type. For H4, it's pick and place type. Next is Castle. The CDA input port is only 2, but it can also test a material in once. The test type is also pick and place. Next is the LT. The CDA input port is only 2. It can also test site quantity 8, but the test type is gravity 1. Final is Rascal. The input port is only 1, but it can test 32 material in once. And the test type is the strip. It's a test with a different, so it calls strip. And the second step is align with stakeholders. This is my CDA measurement job plan, and in the first I will do some pre-work for like CDA study and measurement plan discussion. Also wait for the measurement tool delivery and get familiar with the test area or to test our measurement tool. After that, we will do some measurement. The first, I do the H4 measurement and I complete 94%. Because some of the H4 is unidle, so I cannot measure it. And after that, I will do a data analysis for this data. And finish that, I will do a Castle measurement. You can see I only finished 14 in the Castle measurement. It's because I made some problem in measuring the Castle. I will talk it later. And next is LTNT measurement. I finished 65% of the LTNT. And I also have some problem in measuring the MT. So I only finished 65% of the LTNT. And next I will do some remeasurement for the handler. Also do the CDA pressure distribution for the MB third floor. And also this is my goal. And my goal number one is to complete 70% of the handler for CDA measurement in MB third floor. But I only finished 15, but because of the MT and the castle, so remove it, I finished 70% of the handler in MB third floor. And the second is to complete a measurement of pressure map in MB third floor. And third is identify the leader and the core team. Casper assigned me to do this CDA research, and Milo is my buddy, so he helped me to do the data analysis. And the testing sub leader is JH. He assigned people to help me to do the measurement. Equipment engineer like Eric Liu is for H4 and Rasco. And CCD is for Castle and LTNT. And this is my developed detailed plan, the preliminary evaluation. We also do some pilot. We ran for the H4 in middle of the June. And the second is my measurement. As you can see, this is the H4. I put on my flow meter, and in H4 we have 4 ports. And finally we got the data, and I will show the data for you later. And in measurement, I also meet some challenge. The first is coordination, because at first the RM, we call AE, in the court, they didn't know what I'm doing to measure, so I have to communicate with them. And the second is operator, because I don't want to bother the operator's testing procedure to interrupt them, so I have to waiting for the shift changing material for RM. And the next is field measured in Castle and MT. In Castle, once I put on my flow meter, it will cause the pressure drop from 0.6 megapascal to 0.5. And it will cause the pick and place problem for Castle. It will drop the material, so I cannot measure the Castle. And MT, because the type of MT is old, so I take off the CDA input, it will crash. We have to restart it, so the test procedure need to test again. So I cannot measure the MT. So we have some alternative. I also asked RM there to help me to do the measurement and wait for the notification for test RM to measure the CDA flow. They notice me to changing shift of the operator, so I can do my test measurement to do it easier, because they notice me to when it's the time to they are shifting change. And finally is the proper tools for each type type. Because the Castle, it will limit the flow meter will limit the flow, so we are finding the proper tools for Castle. And in the measurement, I also found some variation of testing condition. The first is the testing temperature. The different testing temperature will have a different flow value, and the site quantity also. The different site quantity, it will also affect the CDA flow, and the packaging size. Because like LH4, different packaging size, you will use different type of the chalk. So the CDA flow may be different. The final will be the handler type. Different handler type will got a different CDA flow value. I also do some action lists for my measurement plan, and in this, we have 3 lights for this action list. The green light is for I complete for 100%, and the yellow line is I complete above 50%, and the red line is under 50%. And you can see there are numbers in the action list, and the number is for the handler quantity. So like for measurement, I start in the week 4, and the forecast is I have to measure 6, but I only measure 4 because it's my first week to do the measurement. And I also made some problem in measurement Castle and MT, so it's a red line. And LT, we have some idle, so it's a red line. Red line. And in this step, I will show you my data record. for this is NT. You can see the flow here is very unstable. So we have some problem in LT for the data record. So in this part, we are not showing the value of the LT because of the valuation of the data is very big. And this is the for H4 is for the low temperature. You can see it's more stable than LT. And the step we record the data for H4 is we record per 2 seconds to record data. After that, we do an average for this data. And next is the average CDA usage of different handler. So we build up 3 Pareto to show the different temperature. Like we have high temperature, ambient, and low temperature. And the y-axis here is for CDA floor. The unit is SCFH. It means that standard cubic feet per hour. And you can see the total usage of the low temperature. H4 is used very high because only under low temperature, H4 will use 4 ports. But under high temperature and ambient, the H4 only use 2 ports to supply the CDA. And I will talk it by temperature. The first is a high temperature. So I found some differences in H4. The first is AM51. The port A and B have a lot of differences between these 2 ports. Second is AM51. I do twice measurement between these AM51, and the port B have differences between these 2 measurements. And the third, AM48 and AM42. These 2 handlers have a different value under the same testing environment. I do the trend chart for these 3 differences. The first is AM51, port B, the measurement 1, and the second measurement. You can see the frequency is also the same, but the second measurement is lower than first measurement. So I got some opportunities from it, like the same handler, but we have different outcome in different measurement. And the second is AM51 port A and B. The frequency is also the same, but the port B is higher than port A. So the CDA consumption differences between these 2 ports, and the total. But although these 3 port A and B have a lot of differences between these 2 ports, but the total usage of these 2 ports are also the same. It's about 400 SCFH. And the AM48 and AM42, we made a comparison, and it has 45 SCFH more CDA consumption from AM42 compared to AM48, and it might cost $130 per year. Next, we are going to talk about the ambient. And in ambient, we also found 2 differences in this ambient situation. First is AM42. The total usage is lower than AM46. The next is in RESCO. The test environment is also the same, but I measured 3 handlers, but each handler's value is not the same. So I use a Pareto. First is compare for AM52 and AM46, and there are 55 SCFH more CDA consumption from AM46 to AM42, and it might cost $128 per year. Second, I do a RESCO Pareto. You can see the flow is stable here, so I compare with AM05 first to compare to RS27. It has 91 SCF more consumption between these, and it might cost $211 per year. And next is the RS05 compared to RS23. It might have 73 SCFH more CDA consumption. It might cost $170 per year. Finally, we are going to talk about the low temperature, because low temperature, the H4 might use more, so the CDA consumption might have a lot of differences between the H4. And also found 2 differences. First is AN61. The port C and D have a lot of differences between these two ports. Second is the AN61 and AN60. It's under the same testing environment, but the port A and B have a lot of differences between these two handlers. You can see the Pareto here, the AN61 port C and D, the first measurement and second measurement. The first measurement, it had top and the lowest in this trend chart. So, and the second measurement, the port C and D is on the middle, is between them. So, after that, we have found an opportunity. There are 23 SCFH differences between these two measurements. So we might have $54 cost per year. And the second is amount of the AN61 and AN60. We have a 150 SCFH CDA consumption from AN61 to AN60. And it might cost a lot. You might have a $346 per year cost. And the next is the CDA pressure map in the MB third floor. We found this area has the lowest pressure in the MB third floor, and we come out two results for this kind of situation. The first is that the left side of the MB third floor, we have a sub duct for the left side. So you can see the pressure in the left side of the MB third floor. The pressure is higher than right side of the MB third floor. So it's the reason why this area is the lowest. The second is we think that the castle's usage is higher than the other kind of the handler. So you can see the castle area also lower than the area. Is the lowest in the left side of the MB third floor. So this is the periodic evaluation. First, I check with the flow setting with the handler with the RN. I also asked Sheng'an is the RN in the MB third floor. They told me that the H4 setting in the same temperature will be the same. And the second, I asked RN for the test procedure. I also asked Sheng'an which kind of procedure may consume the most CDA in the test procedure. Second, I'll do some remeasure for the handler which have different flow values. As you can see, I do a lot of remeasure between the H4 under the same temperature. Finally, I asked Aurelio for H4 for each coordinate meaning, and he gave me these instructions. And this is my summary for CDA research. I will set it by 3 parts. First is from flow. We have 578 total SCFH CDA waste. It might cost $1.3K per year for H4 in MB4, and it also about only 10 H4 I measure. I do the differences between. The second is 104.
That's only for the ones you measured.
Yep. Okay. Then 164 total SCFH CDA waste. It might cost $0.4K per year for RESCO, and only for 3 RESCO I compared. And from pressure, we found the pressure in castle area is low, and we have a big pressure variation in the MB third floor. So, and other, I also found some problem in shift changing usage, like this. Once I go to do some measurement for the H4 in low temperature, and I put on my flow meter and waiting for the test procedure is over, and I came back after 2 hours, and the test is over, but it's still purging, because the H4 may have to maintain the low temperature environment to do the next material test. So they are idle for waiting the shift changing. So I think that it is a chance that we can solve the CDA usage. The next is when I do the pressure map, I do found some tube leakage. And third is the white tie fitting leakage, like this. The resources of the CDA input port is not enough for each type of handler. So they also use this type of the fitting to do the branch. So it might cause the leakage. And this is the calibrate. And this is the future work for the CDA. And I'm thinking that we can do some balance the pressure distribution in MB third floor and find a way to measure the castle too. And the flow value have differences under the same setting that we can work in the future. And the way to record the data of the LT, you can see the data of the LT's variation is very big. And know each port meaning for H4, I will talk you later. And finish the pressure mat in every floor. Fan out to measure all tools, not only focus on H4, RESCO, okay, we can also measure RESCO 2000 and H like this. And add resources port like the white fitting, because the resources port is not enough. So I think that we can add resources port to down the leakage. And use vacuum to replace some port. This is Casper is working with the equipment engineer for LH4, Stanley. Because LH4 use CDA to do some pick and place procedure. So he's thinking that to use the vacuum to replace some port, the port function to do the CDA reduction. And we have to measure the assembly for because we only focus on testing for now. And how many testers will continuous purge with the CDA? Like I just said, they are waiting for the shift changing and still purge in this idle time. So this is the future work we have to solve.
Tim, this is a break. My boss rearranged his schedule, and I have to go to a conference call at 9, so I will leave quickly. But thank you for your work. I'm just telling you, so when you see me leave, that's why I have to leave.
Okay.
Thank you for your presentation.
Okay. Next, I'm going to talk about the facility management system. The facility management system is a system to let us to manage our assets. So the first is the asset. We can manage our asset in this facility management system. So we can see we have how many compressors or vibrator and nitrogen tank. So we have a job plan for this asset. Because some maintenance or some check. And we also have a scheduler to define the frequency of this job plan for the asset. And after that, we'll come out with work order to remind you when the work will start. And finally, we'll have a report to report the status of the job plan. And this is my FMS practice. I work with the idiot. And first, I have to find out some asset I'm going to work. And next is the job plan I built, like the nitrogen tank check, and the vibrator check. And next is the schedule to define the frequency. Like the vibrator, we have a daily check, or the nitrogen tank, we have a daily check, or some an annual check. And finally, we'll come out with work order to remind you the target start date will be September 1st. And finally is the internship sharing. And in my internship sharing, I'm going to talk about two parts. The first is learning a lot in facility site, because before I come in here, I didn't know what facility should do. And after here, I learned a lot, because this system is I never learned in the school. Like assembly, I can learn the assembly theory in the school, but like CDA system, DI water system, or drain system, I didn't touch it before in class, in school. And a lot of meeting, because people are also busy here, and a lot of meeting, and when I finish a meeting, and another meeting will go start. And I think I learned a lot in communication, because I have to communicate with the test site, and great work environment. Like Casper treat me well, it do teach me a lot of the system, how it works, and not only on the works and technique, he also told me how to communicate and the work emotion for work. And Willow also teach me a lot for how to make a great present and the data analysis. And I also have great activities with other interns that celebrate for the Father's Day and sing for third quad meeting, and have a dinner with other interns. And thank you, this is my panel review.